Kia ora koutou katoa, Sarah Oliveira here as usual. I am just recording this session for the sake of those that can't make it today. So we're going to get into it. Um, the session's about integrating real world contexts into your teaching. So we'll probably look at some internal based topics, but basically, how are you engaging students into the biology around them? And that's really what the main point of the topic today is. Um, just, and I'll just do a wee quick karakia. He te we whaia te mā tauranga kia mārama, kia whaitaki ngā mahi katoa, tu maia, tu kaha, aroha atu, aroha mai, tātou ia tātou katoa. Kia ora. So, what are real world contexts? Real world contexts are authentic, meaningful situations from students' everyday lives and communities that frame the learning of biology, accept, concepts and skills so that students see direct purpose, relevance, and transfer to beyond school life. Um, and I mean, they are what they say they are. They are essentially taking real world contexts and bringing them into the classroom and trying to incorporate that into the teaching that we do. Yeah, and it's essentially a context-based approach, which is a very widely referred to content piece of literature that a lot of academics have referred to in the past, and it is even more recently written about and incorporated in education literature. So, in general, context-based approaches is not just an add-on example, and it's really important that we're not just saying when we're using examples. It's the ultimate structure of what we teach and how a topic is investigated. The context is the topic, and we teach around the context rather than concepts to that are supported by contexts. So it structures what is taught and how it's investigated, so that concepts are developed through the context, not after it. That's really important. I've listed that reference at the end from Honey Fidel. Characteristics of real world contexts, authenticity and relevance, very straightforward there. They're authentic, and they connect new biology to lived experiences. So whether you're listening to your students' lived experiences and going with that and trying to explain the biology of that, or whether you are looking at the news yourselves, and then just incorporating that into the classroom and the way you teach, it's really your decision. It is a context first sequencing, so you begin with the context. Um, yeah, that's pretty straightforward. It's a concrete situation, or sometimes it's not always concrete, or you might even just start with a question that's maybe controversial, but that could stimulate the conversation. You align with disciplinary practice. So this characteristic, sorry, of real world context, it has to align with what kind of a general activities model, and how scientists work. So it's more of a you're mimicking the processes of scientific process in the classroom, a bit like how an academic might work or how a scientist more specifically would work. And then it is based and founded on the concepts of cognitive and social constructivism. So they're building new understanding and knowledge through social connections and situational sense making and discussion. I really love this way of learning, and I feel like personally, anyway, is it's a feature of why we need classrooms, why we can't just rely on AI to teach students, which is what I think some people still try to do. That cognitive and social constructivism is a real need in society, but more importantly, how do we grow that in students so that they can go out into the world and use those skills? So we're kind of developing those skills in the classroom. So, with all that said, why real world contexts? Well, first of all, they're really relevant to the students. So, what are the benefits of it? Students are so engaged in what's relevant, I find anyway. So, if it's interesting to them, if it's appearing in their news feeds, I mean, something that you could ask them at the beginning of the year, what's appearing in your news feed? What biology are you experiencing in the world around you that you would like to learn about? It's a very simple question, but it could actually frame the way you teach. There's ultimately increased engagement and understanding. I think that kind of would be easily seen in a classroom. But this is actually academically referenced as well. So there are numerous studies that have said this, that have found this. There was increased engagement and understanding. It situates biology in the real world problems. So students actually have an application to the biology they're learning in the world around them. That's not just a foreign concept, like a lot of students will say when they leave school, they don't use any of the maths they learned, which I don't think is true. But anyway, I think you need a bit of maths at least. But yeah, like with biology, we're giving them a real world problem to apply it. Um, it stimulates higher critical thinking gains. So students are actually critically thinking more because they've got a problem to solve or they've got an issue that's surrounding them that they would like to contribute to. And it prepares students for future societal changes and also kind of gives them a civic, like, engagement into those societal changes, perhaps, where they might think they can have something to say or do about it. Some examples of real world contexts. Local ecology, that's actually really easy in New Zealand. I'm going to give some photos of this shortly, but like Rocky Shore, for example, or even going for a hike up a mountain, there's a lot you can look at for biodiversity in New Zealand, and it's very unique. So it's very easy to incorporate that, even if you were just doing external based stuff. Biotechnology and ethics. This one's very easily incorporated for this because there are some big overarching questions around the biotech stuff. And actually, it probably marries up more than any other subject area. This biotech is probably one of the most interesting ones. So especially the year 13 3.7 paper, that one's fairly good to overlap with this. And the 91602 as well. I'm going to go through the standards that could be incorporated here. And then public health and immunology. This one's pretty easy to do because of the socio-scientific aspect of it. So any of the immunology or vaccine framing information around vaccination, anything that's sort of even somewhat controversial, I find the vaccine stuff is very controversial. And that invites that conversation around social and ethics that becomes a very real world context. And then field lab investigations, like can you ask them questions about water quality, for example, and can they go and test it? Can you create an inquiry-based approach to incorporating this in the classroom? So just some New Zealand, I guess some standards that we could link to real world contexts. First of all, we have the achievement standard microorganisms that we talked about a couple of weeks ago with Erica, the 92020 CV 1.1. This one's pretty good. It could lend itself really well to this because you'd end up incorporating local microorganisms or even case studies or diseases that have been spreading in the area. And it's nice to link to, I guess, not just viral diseases. In this case, it's probably better to even do the fungi and even other organisms in the area, but also to link to investigations that you can do with those students. So this one's really good for it. And then the rest of the science, what those three science ones here, which are 1.1, 1.3, 1.4. I didn't put 1.2 in here because 1.2 is more chemistry, but in general, it could actually lend itself really well to this. But the one, they're all pretty good. I think the local issue one, the science informed, this is perfect for it because you're actually looking and a science behind a local issue. So find a local issue and link it to that. I think this one's really great for that. This is perfect for context-based approaches because it's local. Again, the next one, 1.3, also does that with describe features of science that have contributed to development of a science idea in a local context. This is a bit different because you're actually looking at the development of a science idea. So you've got to find one that has developed, has been developed over time. And then this one here, Science 1.4, I really like. So this is demonstrate understanding of science-related claims and communicated information. So you're looking at different communicated information, and then you'll get basically developing critical literacy with your students. Those skills that they need in a context-based approach. So it's actually really great for this too. So those new standards were great. I'm not going to sure how long they'll last. Level two, you've got the 91153 practical investigation. And then that one's, again, like any practical investigation, is demonstrating science in the real world. So you're actually doing context-based approaches. It's just the fact that you are having to give the students the context. So you have to think of a context that might be different from making chips, for example. But thinking of a local investigation that would be at level two of the curriculum, I think could be relatively difficult to meet the criteria for level seven of the curriculum, but it would lend itself to this topic, to context-based approach. 911 or cells and gene expression are both externals, but you could include contexts as you are teaching them, which would engage your students a bit better. And also, they're quite dense, so it's nice to have those contexts to break it up. Then you've got 91158 ecology. This one's fairly effective for this. And in fact, probably one of the better ones out of all of them, as mentioned already in the slides. I've done this zonation on the Rocky Shore, and I've also done stratification. Those ones are fairly good, but you're giving them contexts. They're investigating. There's a lot of choice. There's a lot of inquiry, and then they're doing data analysis as well. There's a lot of that in there. And then microscopes, you would be looking for local organisms, or you might take them on a field trip and gather the microscopic organisms that from the world around them instead of perhaps giving them these specimens. Perhaps you do it in the development of the actual assessment, and then the assessment, you give them those contexts as normal. Um, then level three, practical investigation. Again, you'd be looking for a local investigation. This one is actually quite easy to do. The problem is to making it, streamlining it so that students are all investigating on their own. So they're essentially able to develop their own investigation. And I think we encourage them to do that, but just making that and encourage them to be at level eight of the curriculum and incorporating it. So this topic actually is very context-based and could easily be that. Socio-scientific issue, again, perfect. Socio-scientific issue is one of the best ones for this because of how you can pick any issue and you can do local and you can easily, in fact, I think it's the best way to do it. Pest control and vaccination are the most common ones, and vaccination because it's very controversial, and pest control because it's usually very local and a little bit controversial as well. Um, yeah, and the methods that people use, but there are all of the elements of investigating the media, students engaged, homeostasis as well, but I think this one is a little bit difficult, a little bit more challenging to localize, although it can be very easy if you have got a good local context for a case study of someone doing having to or having suffered cold extreme temperatures or extreme cold temperatures and or glucose regulation, perhaps have a diabetic in your life. Or you could do a case study around that. But bringing in local speakers on this would be really helpful. But yes, you could make homeostasis quite context-based. And human evolution speciation, obviously externals, a little bit less. You can't really do them as context-based because they're very prescribed, but you're also looking at local context or, sorry, more recent findings in local fossil sites. So those could contribute to this. So make them a little bit context-based, especially for the speciation and the New Zealand fossils. Biotechnology, very easy to make this context-based. And in fact, I think the slick cows approach is really good. That's that task that came out last year on Bean's website. How do you engage students in the real world aspects? Well, first of all, I would just say read the news, watch the news. What biology is in the news lately? Have you had some debates around biotechnology, or is there GM arguments going on still? Um, they're still happening, actually, they're happening all the time. Um, and then so what's what I'd start with first, and then secondly, start with the context. Don't teach any material. Start with the context. Hey, look, we're going to open up the argument around vaccination today. Do you think vaccines should be mandated? And then here's the context. And then try and bring in some biology around it, and then obviously some social elements and things like that. Um, Number three is make it inquiry based, but also scaffold learning. So while you're maybe teaching about vaccination, you're also maybe scaffolding the way that students learn. that material. Maybe you have to teach and scaffold the immune system and say, look, in order to understand how a vaccine works or vaccine-induced immunity, we're going to have to know how the immune system works, and we're going to have to look at innate and adaptive immunity. And so you can take them through how B cells and T cells are generated. Um, and then you teach them the research skills to be able to determine how valid information might work. So these might come in as after perhaps you've, or before, you've been teaching some content around it, but needs-based approach. And then bringing guest speakers. I really love incorporating guest speakers, especially for that 91602 paper, because you can get viewpoints anyway. They're required to do that. You can get guest speakers on any topic, by the way. But use people in your school if you can who've got experience in certain areas of biology. Nurses are really great because they can explain some of the public health stuff. They can also give perspective and they can also talk about their experiences talking to people. Yeah, and you could also invite someone else in the community that you might know, and it's good to know people. But my theory is just go out and start emailing. If you want to and get someone in as a guest speaker, start emailing them, see if you can get them in. Or go on a field trip, which is number five, obviously go on a field trip to somewhere nearby that links to your context. And can you get the person delivering the field trip to talk about the topic that you need them to talk about? Can you give them some information about what you need them to tell you? And be explicit. Sometimes they're not clear on what's in their curriculum the students need to know. So if you tell your speaker, often prep them really well, they'll actually come with a good amount of information. I've had guest speakers that have come and prepared whole talks on materials that students need to know for their topics. And yeah, it's been really robust, really clear, and also academic, and where it's just added weight to what I've done in the classroom. And then encourage students to interview people in their world. So if you're making it very context-based approach or inquiry approach, then you're going to get them thinking and inquiring about the people in their world that they already know, that they can get authentic understanding from, rather than just looking it up online. And the reason I say this is because we're trying to encourage critical thinking in our students, and often that critical thinking just lends itself to going online and searching stuff up. But we want to try and deter that a little bit, and we want to try and give a bit more robustness to students' learning experiences and application to real world environments or real world contexts. And this is why I think actually this topic is really important even now, especially now in the AI age. So here's a little, I've modified this context-based learning model from Beasley and Butler's paper in 2022, very long time ago, yes, but it is quite modified. I have done this on Canva earlier, and because I was trying to contextualize it. But essentially, here's a bit of a flow chart. So how you might do it might start with the students' activities, where you entry into the context, where you introduce the learners to the world situation, establish relevance and secure learner engagement. And then you would invite them to inquire, do some investigative work, questions from the students. So you're trying to encourage and establish that they're now moving into an inquiry. Now, whether you do that in the first lesson or whether you do that in a series of lessons, it's completely up to you. And how you engage them is important, because you don't want them just loosely wandering. So you do have to kind of scaffold what students are doing. So you might have to create some questions, so some guided questions perhaps, to invite your students to that inquiry process. Yeah, that's what I tend to do when I'm beginning my topics. But I usually do most of these two things within the first lesson or two. And it depends if you've got a soft launch into your topic, or if you've got a really hard launch into the topic. So completely up to you. You could start with a movie or, like a debate, or you could start with something very interesting. Who knows? Um, Make it elaborate on the context, sorry, context elaboration. So this is where you might bring in some teaching. And this is the knowledge inventory that might come in, where you become part of the picture. And I've added this teacher input thing because I felt like it's important that we understand that teachers might help with this part, the context elaboration, and also the detail students might need to include in their elaboration of this context. And then defining the problem, initial hypotheses, and then framing that problem would come in next. So that might come in further down. And it might not just be framing the problem, it might also be giving breadth and depth to students' understanding around this. You could help with the scaffolding of this. Hey guys, we're on framing the problem today. And what does that look like? Are you looking at different perspectives to understand that framing of the problem? Are you hearing from everybody, remaining open-minded? Are you looking at the social elements of this problem? Economic, whatever. And then do they need to carry out research, investigate? Do they need to do analyses in order to be able to understand that problem a little bit more, get more depth, get more scientific literature, and then lastly, apply their knowledge. And this could look like writing up their report. That last bit would be applying their knowledge. But notice how little of this time here, of this whole procedure, is actually writing reports. A lot of it is just understanding the problem first, getting context, getting understanding, elaborating on the context, investigating, framing the problem. All of that is all about understanding and building a grasp and open-mindedness around the topic. And then they apply their knowledge, but they don't do it until the very end. And they're also developing skills along the way. And then obviously the last bit, the exit from the context. So you might do that debriefing after having marked an essay, or you might do that, allow them to do some feedback or whatever, or they do their own reflection on the topic. And I've kind of put this into a flowchart into how I might do it with MMR, for example. This is an MMR context. I have done MMR in the past. I've done COVID in the past. I tend to change my vaccine to do going with what's going on in the news and what outbreaks we've got, and I'll stick with what's current and what's local. Some areas might have more local context. But vaccination is really easy to talk about with this, so I've chosen that. But I would say that you could do it for many different things. But yeah, that's essentially a good framing of what this might look like in the process. And when they apply their knowledge, I've actually added things, like you could do infographics, you could get them to do a podcast, you could get them to explain the importance of MMR vaccine instead of just writing an essay. Can you get them to do it in a different way that's slightly different to the past, but would actually allow them to draw on their knowledge and include the same kind of information as maybe an essay would? I realize marking an essay is much easier than marking a podcast, but how good would authentic learning be at that point? How inauthentic would that become? And if they're going to become a radio announcer, who knows, that might actually help them. Here's the reference list just for some of the research I've referred to today, but I will be setting up this reading because it's the only one publicly available that I can give you. It's a really good one. It's yeah, obviously a few years old, but fairly good.